So inverse, once again, one-to-one relation only. That's why, okay, if we take a look here, okay, for sine hyperbolic, can you tell me, take a look, this green, green, so can you tell me, is it one-to-one? Is it one-to-one or not?
Yes, sir.
Okay, one-to-one, because when you are taking one value of your x, your domain is actually you are getting one image, and for one image you are just having one object, similar lah. How about this cosine hyperbolic? How about this cosine hyperbolic? Is it one-to-one or not?
No.
So this is
Mid.
what relation? What relation, guys? For cosine hyperbolic,
This one-to-one.
are you sure one-to-one?
But I think it's 1, 2, or 2.
Okay, so yeah, two. So basically we say just many lah. Okay, for cosine hyperbolic, this is many to one. Sorry, many to one pula. Yeah, yes, many to one. Okay, why many to one? Many to one. This is your object. This is your image. Okay, object referring to x, image referring to y. So you just draw one line belongs to your y values. For example, here y, I am not sure. Maybe we take, for example, 100. Okay, y equal to 100, for example. But for y equal to 100, just one value of y, but sharing two values of x. One here and another one here. Means that you are having here x star, and down here x double star. Two values of x sharing the same image y equal to 100, for example. Okay, so for this cosine hyperbolic, we are saying we have many to one relation. Okay, just now sine hyperbolic one to one, no problem. But for this cosine, we are having many to one. How can we make it inverse for cosine hyperbolic? I will teach you. Okay, how about this tangent hyperbolic? What is the relation for this one?
One-to-one. It's one-to-one.
1, 1.
How about the values that very close to one? Is it you are having one value that share many x values? One value of y share many values of x.
No, sir.
Very close to one.
No. It's 1 to
Huh? 1 to 1. Okay. Okay, as exponential lah. They are actually different values of y, but the value of y, the different just very small. Maybe 0.999991, maybe 0.999992. Okay, the different when you are taking very large number of x lah. Okay, but they never equal. Let's say you are taking x equal to 1000 and x equal to 1001. Okay, they are not sharing the same y values here. Okay, but their values are very close enough. Okay, very close enough. So this is remain as 1 to 1, because if you are taking one value of y, for example 0.5 lah, so just here 1x, here y equal to negative 0.6, for example, another x. Okay, they are not having two values of x for one y, so this is still 1 to 1. If 1 to 1, no problem, you may get your inverse function, inverse graph directly. But what happened to our many to 1? We have to modify. Okay, if you are having many to 1 function, you have to modify your function. We make some restriction. Okay, I will go for this one after this. Okay, we go for inverse of hyperbolic first. Okay, hyperbolic sine lah. And remember, hyperbolic sine x here, inverse hyperbolic sine here, is not equal to not similar, not similar. If you write like this is actually power. This is not power, this is inverse. Okay, this is inverse. If you are having power, yes. Okay, sine hyperbolic square x. If your power is a positive, then this is similar. You put outside too. This is correct. But if you are having sign in the power is negative, we are rarely put it like this, -2, because of the inverse sign of -1. So normally we rarely write like this. Okay, instead of like this, we just put sine hyperbolic x -2. Okay, we commonly not using this one, but we use this one. If your power is negative, okay, this is negative power. Okay, this is negative power. Don't be confused. Also applicable for your hyperbolic, trigonometric functions. Okay, remember this one. Okay, not similar. If you are having -1, this is bear in your mind inverse, 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 inverse. Okay, for applicable for hyperbolic and also trigo lah. If x -1, this is not inverse. This is power of -1 because x here is not trigo, it's not hyperbolic. X is just polynomial and this is equal to 1 over x. This is correct. Don't be confused. Okay, we just make exceptional for hyperbolic and also trigo function only. Okay. Alright, so this is your inverse function. So since we are having originally 1-to-1, okay, I'm drawing the graph here. Okay, right. So how can we make our own graph for inverse? So as I taught you last Sunday, so we draw one line of y equal to x. Y equal to x. Y equal to x means that here 45 degree and here also 45 degree lah. Okay, that's y equal to x. Okay, you draw this line of y equal to x and then you reflect the original graph about this line y equal to x. So when you reflect this graph, so means that you are getting like this lah. Maybe this is just the what we call it, the sketching lah, sketching. So this is actually y equal to sine hyperbolic inverse x, the graph. Okay, and this is not like our asymptote in tangent hyperbolic lah. This is should be becomes larger lah. Okay, very large, but quite slow if we are talking with respect to y values lah. Okay, they becomes larger, quite slow for y values. Okay, but at the end when you are taking very large number of positive x, okay, so this is tends to positive very large number. Okay, but quite slow lah, similar as logarithmic function. Okay, logarithmic function same pattern here. Okay, this part. Okay, they basically tends to positive infinity, but quite slow lah, quite slow. Alright, so this is your inverse graph for sine hyperbolic inverse. Okay, and if we take a look once again, domain and range. Okay, x values, there is no possibilities of x values undefined. So we are getting what we call it as real number. Same goes to range. Also real number. Okay, real number. All right. Okay, any question so far for hyperbolic inverse sign here? Any question? Class? Your class?
Clear, sir.
Okay,
Yes.
thank you. I need your response unless I feel not comfortable. Okay, cosine hyperbolic inverse x. Okay, go back to original cosine hyperbolic inverse. Cosine hyperbolic graph. Somewhere like this lah. Okay, this is your y equal to cosine hyperbolic x. Not inverse, not inverse. Okay, once again, okay, you draw a line. Y equal to x. Okay, y equal to x. Okay, right. But before you draw this line, before you make the reflection, you must ensure that in order for us to get the inverse function, once again, bear in your mind, one-to-one relation must be one-to-one. Okay, in case of one-to-one relation, we have to modify if our original function is not one-to-one. Okay, for that case, many-to-one lah, like this, cosine hyperbolic. Okay, so how can we make it one-to-one? So you restrict the domain of your original function cosine hyperbolic. Either you take left hand side to make sure now you are getting one-to-one relation, or you take right hand side to make sure now you are having one-to-one relation represent your cosine hyperbolic. Okay, either one. Okay, so for this example, you may take left hand side or right hand side. At the end, you are having one-to-one relation. So let's say if I cancel this. Alamak. Just a moment. Okay, if I cancel this. Is it one-to-one now? Is it one-to-one now?
Yes. Yes.
Okay. You may check lah by yourself. You take one y and then you are having one x, one y, one x. So one-to-one. Okay. So now you are having your one-to-one. So start from 0 to positive infinity for your x. Okay. So now you may reflect. Okay. With respect to this line of y equal to x lah. So since this is the value is 1 here. So here you should get also 1 lah. Okay, 1 here. Somewhere something like this lah. Okay, the most important here must be 1. So this is your y equal to cosine hyperbolic inverse x. Okay, once again, you have to restrict your original domain, then you get the inverse graph. So for this one, now you can read lah. Can you tell me what is the domain for cosine hyperbolic inverse? Domain, x values. Yeah, class?
One.
One, sir.
1 to?
Positive infinity.
Positive infinity
Why you are saying 1? Why you are saying 1?
because it start from 1.
Because, yeah, 1 should be the smallest value of x to make sure our cosine hyperbolic inverse define. In mathematics, we say like that lah. Okay. Okay. 1 should be the smallest value of x in order to make our inverse cosine hyperbolic here define. We can get y values. Okay, the value of y lah. Okay, 1, and then since this is the graph defined here, okay, goes up here until to the positive infinity. So means that only we are considering x value somewhere here to the positive infinity. So from 1, is it included or not?
Included.
Yes, included, because the value of your y equal to 0. You may press your calculator lah, checking. Okay, so if included, so we put this symbol, okay, box bracket and to positive infinity. How about range now? Range. How about range?
0.
0 to
Positive infinity.
0 to infinite.
positive infinity, or there should be some asymptote somewhere here, like this, like this. Is there any asymptote here? Huh? Come on, guys, come on.
No, sir.
No, sir.
Okay, no, because this is just part of them. If you travel very far of the values of your x, so this graph should be becomes more larger lah. And as I mentioned just now, okay, the values of y to get positive infinity is too slow lah when you are taking x values. Okay, comparing to x values. But still, they are tends to positive infinity. Open, is it include 0 or not for range?
Yes.
Okay. That's the way how can we get the graph. Okay. Take a look here. So now, if you can see for hyperbolic sign, maybe inverse maybe no problem because your domain is real number. But for this cosine hyperbolic means when you are solving any problem related to this inverse of cosine hyperbolic, okay, cosine hyperbolic, you are getting x values less than 1, means that you have to reject. For example, you get two values, one is 0.5, another one is 3, for example. So 0.5 you have to reject, okay, unless you might get wrong solution lah. Maybe they will penalize you 1 mark, okay, because you are not understand at all the domain and the range, where your inverse function defined, where is the value of your x for inverse function cosine here undefined. Okay, when we are saying undefined, we cannot find the values. Okay, that's undefined. Okay, so you may try for this one. For this one, quite interesting lah. Okay, quite interesting, but you may try. Okay, supposed to be okay. This is range. Okay, for this one later you are getting your graph. Okay, your domain for inverse. Okay, inverse tangent hyperbolic should be this one. Okay, so in other words, basically, if this is just original function without inverse, your range is this one. In inverse function, range become domain for their inverse. So the values here will be domain for inverse tangent hyperbolic. Okay, you may try lah for this one. Okay, so I just want to go for inverse of trigo. Okay, trigo. So number 3, if you want to ask any question, yes, please.
Okay.
All right. Okay, I start from sine. Sine x, okay? No h, okay? Because this is trigo, okay? Inverse trigo, sorry. Okay, if we are saying trigo, so no h here, okay? Bear in your mind. So, okay, we take a look at the original graph. Okay, sine start from here. And continue. Same goes to the left hand side. Sorry lah. My handwriting is not too good.
It's okay, sir.
All right, and continue. Okay, thank you. Okay, 0, pi, 2 pi, minus pi, and minus 2 pi. Okay, once again, this is x, this is y. This graph for y equal to sine x, not yet your inverse. So previously, you say this is 1-to-1 or many-to-1 relation for this function y equal to sine x?
Many to one.
To one.
Clearly
Yeah.
many-to-1. Okay, just take simple lah. Y equal to 1 here. So we are having here pi over 2. We are having here negative 3 pi over 2. We are having many, infinitely many values of x that give one value of y. Okay, so that's many-to-1. So how can we restrict the domain to make it 1-to-1? How?
Pi over 2.
From 5/2 to 3/2 pi.
PJT, your voice is lagging. Double or lagging, I'm not sure.
Sir, we can take 0 to
0 to pi. Can we take 0 to
2
pi?
pi. To 2 pi actually.
Pi over 2.
5/2 to 3/2 pi.
2 pi.
Pi over 2 to 3 3 pi over 2 here. Is it correct?
Negatif pi over 2 pun boleh kan sir?
So let's say I want to take from here. Here pi over 2. Here negative 3 pi over 2. Just here. From here to here. Is it now you are getting 1-to-1?
Yes.
Yes.
If I take not just to sorry, this is positive. Not just until 3 pi over 2, but I'm taking also here. Is it 1-to-1?
I think not.
No.
Why no?
Because many to one.
Because more values.
More values down here, isn't it?
Yes.
That's why you have just take until 3 pi over 2 to make sure you are having 1y, 1x. Okay, 1y, 1x. 1y, 1x. Okay, 1-to-1. Okay. Yes, this is correct. Okay, you restrict from pi over 2 to positive 3 pi over 2. But let's say if I'm considering left hand side. Instead of from pi over 2 to 3 pi over 2, may I take from minus pi over 2 to positive pi over 2?
Yes, sir.
Yes,
Yeah.
sir.
So
Yes.
which one I should take to make it 1-to-1?
Minus pi by 2 to pi by 2.
Why? Why?
Because
Okay.
it's negative? No.
Negative. This one there is no negative. We are not taking negative value. This one. Okay. Because okay, it easy for you to get your graph when you reflect about y equal to x. Y equal to x. Okay. For this one, you might get different graph when you reflect about y equal to x. Normally, when we want to reflect our original graph with respect to y equal to x line, so we try our best to make sure our original graph somewhere very close to this y-axis now. Okay, so for this case, we are taking from minus pi over 2 to pi over 2. Okay, so we exclude the rest. This one we delete, and also this one we delete. Okay, so we just consider this minus pi over 2 to pi over 2. So I'm drawing another graph, right hand side. Okay, so this is Something like this. And we know that this is the maximum value equal 1, and this is the minimum value equal -1. This should be x equal to 0. So now you are getting your graph here. Okay, and make sure you know that this is minus pi over 2. This is positive pi over 2. So to get your inverse sign, okay, you have to restrict from this minus pi over 2 to positive pi over 2, so that your new domain for one-to-one relation, sine x. So this is for one-to-one. The domain changes. Okay, instead of we are having real number, okay, the domain now just from minus pi over 2 to positive pi over 2. Okay, this is for one-to-one sine x. Okay, and the range now becomes similar. Okay, this is similar as our original sine x. So we are getting -1 to +1. Includes both lah. Okay, so now you may draw your graph lah. Draw your graph. So I'm not sure where is y equal to x. Pi over 2. Pi over 2 should be 1 point something, isn't it? Can you help me? Press your calculator. I don't have my calculator here lah. Pi over 2. Pi is 3.141, isn't it? 1.5 divided by 2, 1.5 plus.
1.57.
1.57. So it should be this is larger than this one. So if -1 should be somewhere here. So my y equal to x should be cross lah. Cross somewhere here, cross somewhere here. Okay, y equal to x. So now you draw your inverse graph. Cross lah like this. Tak cantik lah. Tak maaf lah.
It's okay, sir.
Okay, so you are getting like this, somewhere like this lah. Okay, then this is your y equal to sine inverse x. So now, okay, you get your graph, but we have to determine our domain and range for this inverse sine. So can you tell me what is the value of this one and this one? For this y, what is the value here?
Pi over 2.
Okay, good. Now this become pi over 2. And for this one, x value?
1.
As I did mention just now, we change, okay? Range become a domain, domain become range in inverse sign lah, okay? So now for your domain of sine inverse, that should be, okay, this one also. Okay, this is negative pi over 2. And up here should be 1 minus. So the domain now becomes, okay, include 1 and also -1. Same goes to your range from minus pi over 2, pi over 2. Okay, is it clear? You want to ask anything here?
Sir, I
Yeah.
want to ask, domain and range in here is fixed or it can change follow the question?
What do you mean change?
Maksudnya
For inverse, you mean for inverse here?
inverse dengan not inverse punya. Dia fix ke atau dia boleh berubah ikut soalan?
Okay, if you are talking about inverse sine, this is strictly will be your domain and range. There is no other domain and range for sine inverse. Okay, if you are talking about domain and range for sine, so you use the original one. Where is it? This I'm not writing here. Okay, real number lah, real number, and the range for your sine is -1 to +1. Okay, when we are having problem regarding sign, okay, sign, just common trigo. But if you have problem, okay, you want to solve related to inverse sign, then you have to use this domain and range for inverse sign. Is it clear?
Maksudnya kalau untuk inverse, dia fix untuk yang ini je lah.
This one only.
Sir,
Thank you, sir.
All right, yeah.
what if inverse sine and 2x? So the domain and range will be different, right?
You mean in the question we are having sine inverse x equal to 2x, something like this?
Yes,
Yeah.
or yeah.
Or
No,
sine
2x.
inverse x to x equal to 0.
No, sine inverse sine and then 2x. Is it possible?
What do you mean n to x? I just want to know, is it in this equation or
So y equal to inverse sine 2x.
multiply?
Yeah.
You mean okay, product. Like this.
Yes.
Is it correct? This is your question?
Yes, sir.
Okay, when we solve this one, but don't worry, you will never solve this one. Okay, if you want to get the graph, you just use Desmos for this one. Okay, but what I want to say here, okay, this is just a function. Okay, this is just a function. Normally, this the form of the question should be like this, or like this. Okay, right. Okay, I delete the one. This the third one. Okay, let's say this one or this one similar lah. Okay, similar. Either one. If in your question you want to solve, so when we are saying solve, we need to find what is our x that satisfy our original equation. So take a look here. Your x here belongs to inverse, and also your x here belongs to polynomial. We know that polynomial, there is no issue. Okay, because polynomial x power of 1 just straight line like y equal to x from minus infinity to positive infinity. No issue for this one. So if you solve this one, you get your solution x equal to 5, x equal to minus 10, for example. It's okay, no problem. Applicable for this part. But as I mentioned, it's not we are just looking at this side. We have to look at both sides. Means that if your x is equal to 5, x equal to minus 10, for example, when you solve, let's say you are getting like this, the answer. So you have to make sure, okay, the selection of your solution should satisfy the whole equation. Okay, maybe for this one, no issue. 5 and also minus 10 still does exist lah. But for this one, no. Take a look here lah. Okay, x for inverse, minus 1 and 1. Oh, maybe this is not good. So I'm taking maybe very quite small. So negative 0.5, for example. Okay. So when you are seeing, okay, this side, negative 10, exclude. This is not in our domain. Okay, means that to make sure the whole equation valid, correct, true, okay, we have to reject this one. Because if we substitute this one into this x and also this x, okay, so this is undefined. Okay, but for this one, when you substitute into this x and also this x, no problem. Okay, satisfy both sides, for example lah, for example. Okay, so we just accept this one, but we reject this one. Is it clear?
Yes, sir.
But it is not just checking like this lah. Later I will show you lah how can we check. Okay, it's not just checking like this. All right. Okay, so I delete this one first. Okay, this is sine, and I think already 9:51. Okay, I start recording.